I'm going to lighten the topic just a little bit here, I think, in a couple of ways. I'm going to talk more about just sort of flat work, sidewalks, not so much on the structural side, and then talk a lot about some of the common misconceptions, then providing a little bit of background from some conversations with contractors that we worked with on projects, excuse me. I do want to mention throughout the presentation, obviously this isn't intended to be a commercial, but I work for Mateenbar, so our bars are going to be Mateenbar and its predecessor Pinkbar, which was the Owens Corning product. Some of the same technology and some of the projects that were done prior to Mateenbar taking over that interest. So if you see pink bars, that's why, same product, just a different color. So again, we've heard a lot today about GFRP compared to steel. I really view going late in the day here as kind of a recap of all that we've seen throughout the day. I'm going to talk a little bit of some of the things that Vicki mentioned and Will in the morning and others throughout the conversations. So I won't skip around too much because I know some of you haven't been here all day, but I will try to highlight and recap, as I said, some of the conversations. So we've heard throughout the day, stronger, lighter, rust-proof. It's meeting and exceeding codes and specifications, and we're going to talk about that as we talk through some of the common misconceptions. The first of which is code approvals, right? Lots of questions throughout this, GFRP isn't approved for use yet, so it's going to be harder for me as a design engineer to experiment. Well, this is a big misconception because as we've heard throughout the day, there are ASTM specifications, primarily D7957, that list the physical, mechanical, and durability requirements for the GFRP bars for use in structural projects. And we've heard mention as well the ICC evaluation reports. The ICC acceptance criteria, AC 454, includes bond testing, tensile strength, and modulus of elasticity. We've heard this mentioned throughout the day. I know our focus this afternoon is on slabs on ground, but some of the questions, as I was talking with designers, came around residential, so I'm going to segue just for a couple of slides here around residential. So misconception, GFRP doesn't have any residential codes though, right? Well, that's a misconception as well. It's included in Appendix D of the Masonry Society Code 406-606, which are the building requirements for masonry. And we've heard many, many times through the day about the ACI references that can be used for design, most notably the ACI 440 Code 44011-22, which has the latest in the design methodology. Will talked about this document as well in terms of being a design guide for some of these pre-engineered projects. MNL 6 has a lot of examples, including some on slab-on-grade, as we've heard through the day, that could be some great references. There's tables in there that talk about basement walls and some slabs-on-grade as well. So continuing on with the theme of the misconceptions, well, GFRP bars can't be bent, can they? Well, this is a half-truth, right? They can be bent, but they must be bent during fabrication. So here's a couple of examples, certainly on many different shapes, spirals, etc. So they can't be field bent. This is absolutely true, but they can be manufactured in the factory according to shapes and quantities that would be specified by the contractor, just like steel rebar would be specified and then fabricated in a fabrication shop. It's compatible with most of the standard bend shapes that you have for steel, with the exception of a Z, as you might imagine, because it's pultruded. We can't pull it back on itself, and so we can't form certain shapes, but the majority of the shapes are perfectly fine. There is a strength reduction around the corners, which we haven't really talked about too much because we haven't talked much about bends this afternoon or throughout the day at all, but that's worked into the design specification, so that's already considered when we're talking about FRP. And from our perspective, the high quality of production ensures that we're meeting those strict compliances with the tolerances. There's no way for the bar to be over or under bent because you're forming it around a die, and so it will be exact every time. Again, a little bit of a half-truth, GFRP floats. We did hear this, and this is true. But the contrary is also true. Because it's more flexible, we are wanting to support it maybe in more often and or different ways. So the anchors, the form savers or the bar supports and the ties themselves are serving as anchors. So not only from preventing them from floating, but preventing them from sagging and being too close to the bottom of the slab, which we've heard a little bit around today. We want to be keeping the bars, regardless of a material type, but in this particular case, GFRP, in the place where we want or expect them. So again, just ensuring proper placement and form ties and anchors will make sure that your bars are in the right place. A bit of a misconception here, again, talking about elevated temperatures. So the misconception statement here is, well, because of the resin, GFRP can't be used in any occupied structures. Well, this isn't true completely. It can't be used in fire-rated structures, this is true. And the 440 code does talk about a limit in service temperature due to the glass transition temperature of the resin itself. But that service temperature limit is 185 degrees Fahrenheit. I don't know about you, but I don't want to be in any building that is 185 degrees Fahrenheit. So there is a restriction, but I would say not a large one, and especially with slabs on grade or residential, as I've just been touching on here this afternoon. There are, for your typical residential structures, egress recommendations and requirements really are well codified, and so that shouldn't be a concern with some of these structures that we're talking about here today. Another misconception has been mentioned many times throughout the day, crack widths. Well, GFRP designs really are going to result in unsightly crack widths and unsightly cracking. Partially true, as we've talked about a little bit, because of the lower modulus. Obviously, the design is often governed by serviceability. And the allowable crack widths are nominally larger, allowable crack widths in the code. But as we've talked about, we can design around that. And using sound construction practices like proper curing methods, et cetera, we can make sure that our concrete is placed in the best possible way. As we saw the project earlier just a moment ago from ExxonMobil, a really nominal hairline crack widths are achievable. Well, what about production and availability? These products are manufactured far away and not here in North America. Also a misconception. Mateenbar, the company that I work for, our factory is just outside of Charlotte in North Carolina. Also domestic production. The companies at the top there are based in North America, but there are several foreign sources, of course, like many products. Steel is imported from other countries as well. But where can you find it? In the case of GFRP, there are brands that are available in your big box stores across the country, Lowe's and Home Depot. You can buy them where you would buy your steel rebar from a distributor, or in some cases, obviously going directly to the manufacturer, for some of those larger projects. Excuse me. Next misconception here would be traceability. So once I get the bars to the project site, though, I won't really know what products are which or what I'm working with. This is another misconception. So at Mateenbar, just as an example, because like I said, these are the examples I have available to me. For every lot that we manufacture, we provide a certificate of analysis at the time of purchase, ensuring quality and compliance with the ASTM specifications, similar to a mill cert from a steel mill. And the bars are marked. They're not marked in the same way, obviously, as you would for steel, but each bar is clearly marked with the lot and production, allowing you to trace that back if there were to be any questions about the material specifications or the exact test results for the bars that you're using on your project. I'm going to switch gears in my next few slides and go through a testimonial from the Carolina Boemanite Corporation. They are a local firm to us in the Charlotte area, and they have, over the past 5 years or so, transitioned to using solely GFRP for all of their flatwork projects. And so I talked with them a little bit, and I came up with an example that they provided to me as a project testimonial, a real flagship project. It's called the Apex Loop. It is in the city of Charlotte. It was a collaboration between the private owner, the city of Charlotte itself, and the utility. Because of the specifications that were in place, they were using these very dated 1974 boilerplate, really, specifications. And Carolina Boemanite wanted to think outside the box. And so they talked with the owner, first got the approval from the owner to use GFRP, but then their next step, they had to convince the engineer, and then Duke Energy, who also had some utility poles, light poles, et cetera, that were in the sidewalk area for the specific project. So this is a 20-foot wide walkway with embedded light poles, as I mentioned just a moment ago, owned by Duke Energy. So they approached the engineer. They came with several samples of GFRP bars. They came with spec sheets and details, really talking about how they were going to use it. In this particular case, they were able to downsize. I think we saw that in some of the conversations and project examples earlier. So downsizing from a number 4 to a number 3 to achieve the same specification. So Duke Energy, as I mentioned, they had these light poles in the walkway, and they presented them with an option of using 4 embedded number 10s in a square grid with a square grid, of number 4s around it. Once Duke Energy realized that there was no need for grounding and no need for additional inspections around these light poles, they immediately agreed to use the GFRP. Additionally, the city engineer, who was reluctant at first, agreed to allow them to use the GFRP in the sidewalks. And I'm going to show a picture here in a second. There's a separate band that was poured across the sidewalk, this 16-inch wide band. Because that narrow band was existing there as a separate element, it would also be susceptible to cracking, as you would expect, being a very thin section there in the middle of the sidewalk. And so they decided that, this is Carolina Bowmanite, decided they would just reinforce the whole thing, and that's what they did. 3 years later, there's more than 75,000 square feet of projects that have 0 random cracking. So I'll show you some of the construction site photos here. This is showing that transverse 16-foot strip. It's also in the foreground showing you those light poles coming up out of the page there with the additional reinforcing around the base. And just obviously a nice clean layout of the grid there of the reinforcing. This is just an example of during pouring, typical form ties, typical bar supports, et cetera, everything else similar. So just to kind of reiterate some of this again, really a reduction, again, like I mentioned, going from a number 4 to a number 3, this is saving material cost. In terms of the lighter weight, you're reducing not only your crew, but your transportation. Not only can your workers on site carry more bars, but your trucks can carry more bars, and so you're decreasing labor across the board that way. You're increasing your lifespan of the structure because of the rust-proof nature, and again, being fully compliant with the codes and specifications as we've seen. Just a few snapshots here. These are pretty obvious, as you would expect, but transport to the site. You have a full truck of GFRP here, meaning more bars on the truck. We've heard cutting to length quite easy on the field. The workers love it, just being able to make any adjustments that they would need in that regard. Again, the form ties, or excuse me, the bar ties and the bar supports. In our particular case, and in others of the products as well, the brighter color helps it to stand out from the gravel, so you can see where the bars are. And pouring is really just the same as with other reinforcing. So some specific quotes then from Carolina Bowmanite. What were the main advantages? And they're pointing to this lighter weight, the ease of use and handling. Between the transportation and cutting, they say those advantages make it well worth the fact of not being able to bend on site. And what keeps them coming back, just this the experience that they've had using it on projects over the past 5 years, and them experiencing no random cracking, just makes them question. These are their words, why anybody would not be using it for these types of applications, just being able to get it to the project site quickly and easily and move forward with all the projects. So with that, we'll kind of flip over here and just talk, summarize, performance through innovation here with the GFRP, really built to last and corrosion-free. I'll pause. I think I've made up a little bit of time and see if there's any questions now, or we can hold them until the end, whichever you guys would prefer.
Thank you.
In the end? Okay, no problem.